Yeah, guys, I'm audible. Good afternoon. Yes. Just give me a minute. All right. So, what was the last topic we discussed on? Anyone? What was the last topic we discussed on? And do you have any doubts related to that? So, Wi-Fi password banking, right? So, we discussed about the Wi-Fi hacking scenarios. So, we performed some evil twin attack and air tracking G suit, right? All right. So, today we'll go with a new model called cryptography. So, how many of you guys are aware of the cryptography concept? How many of you? Any idea? And where we use this cryptography? Anyone? Data transmission for security, great. Okay. And any other? Encryption and decryption. Specifically, where this cryptography will be useful and what roles they are playing here. Crafting. Convert plain text to ciphertext. Okay, great. Any other? The process of hiding the code so that only one person, only the person a message was intended can be read. Cryptography is used for in the computer passwords. Okay. So actually, cryptography enables one to secure their transactions, communications, and even other processes which are performed in electronic world. Okay. So like any, it's not only the computer, it's not only the banking, bank cards, or not only a particular person. It is in every sector where the data is processed, where the data is in use, and where the data is in store. On that basis, we implement the cryptography. So if you remember a concept called CIA, do you remember that concept? CIA, which is nothing but the confidentiality, integrity, availability, and even we discussed about the authenticity and non-repudiation too. So where it includes the security for the information systems, right? So where that involves the cryptography part, right? So yeah, confidentiality, what it do? What is the use of this confidentiality? It assures that information, means the data, is accessible only to those authorized to access it. Okay. And integrity, as you know, it's a trustworthiness. So it is used to prevent the improper or unauthorized changes of data or information. And authentication, where it assurance that the communication, document, or data is that genuine or not. And non-repudiation, where it includes the guarantees that the sender of a message cannot later deny having sent the message, and even the recipient cannot deny having received that message. That is what non-repudiation means. It gives the guarantee to the data. So these four elements which implemented to these information security is to protect them from these unauthorized changes or unauthorized access. Okay, so that includes the cryptography only again. So actually cryptography came from this Greek word, okay, so which is cryptos. So meaning is nothing but hidden, okay, or a secret, or a mysterious, whatever it may be, you can say. Okay, secret, mysterious, hidden, or concealed, like that. And graphy is nothing but graphia, they call as a cryptographia. So which is nothing but writing, which is nothing but writing. So the meaning of cryptography is the art of secret writing. The art of secret writing. This is what the meaning of cryptography. So before that, we have a cryptology. So actually, it's a cryptology. Which is nothing but the meaning of cryptography and crypt analysis. So cryptography is nothing but providing security to the data, means hiding that secret code. And breaking that code is called crypt analysis. You're getting my point? Cryptography, as you know, it's an art of secret writing, means hiding the data and converting it to some unreadable format. That is what cryptography. And crypt analysis means providing the security to the data. That is what's cryptography. Breaking the security of the data is called crypt analysis. Simple. It's a breaking thing. Breaking the code. So for that, you should be pro in maths, actually, mathematics. So everything here include with the mathematics algorithms, their theorems, their modular expressions, the prime numbers, all this will be included in this part, right? So we'll discuss about the cryptography. So cryptography is a practice of concealing the information by converting the plain text, which is nothing but the readable format, a readable format, converting the plain text to ciphertext. Okay, so plain text is nothing but here, it's a readable format, as you know. And ciphertext is nothing but unreadable format. That is what we call as a ciphertext. So to provide the security, means converting this plain text to ciphertext, we use a key here, which key or encryption schemas we use. Key or encryption a schema we use. Okay, so to provide a security for the data. So it is a process of converting the data into a scrambled code. That means a unreadable format. Okay, that is what encrypted and sent across a private or public network. So cryptography protects the confidential data such as your email messages, chat sessions, web transactions, your personal data, your corporate data, e-commerce applications, and many other types of communications here. It provides a security for the communications. So encrypted messages can at any times be decrypted by cryptanalysis. So cryptanalysis is nothing but, as I mentioned, it's a code breaking scenario. That is what cryptanalysis is. So even though modern encryption techniques are virtually unbreakable, remember, it's not easy to break them nowadays. So they are coming with a strong algorithms, a strong encryption standards here. So it is a bit difficult for us to break that encryption standards. Got it? Is that clear, everyone? So cryptography is the conversion of data into a scrambled code that is encrypted and sent across a private and public network. So cryptography is used to protect the confidential data such as your emails, charts, like transactions, personal data, corporate data, e-commerce, whatever you have, all that communications can be secure here. Is that clear? And that can be happen with the help of encryption only. That can be happen with the help of encryption. So as you know, decryption, again, converting this unreadable format to the readable format is called a decryption here. So cryptography is nothing but encryption and decryption only. So it came from the Greek word, remember, which is nothing but the cryptos, which is nothing but the hidden or secret, and graphia is nothing but the writing. Means the art of secret writing is called cryptography. Is that clear, everyone? Right? So now the cryptography process, as you know, it's converting the plain text to ciphertext and generating a key to decrypt that. That is what the process of cryptography. So plain text is encrypted by means of encryption algorithms like RSA, AES, DES, all these things. So resulting in ciphertext, which is nothing but the unreadable format. So where that one reaching on reaching the destination is decrypted into a readable plain text. That is what we call as a ciphertext here and cryptographic basis. So I'll give an example. So this process completely we call as a cryptography. So converting the data into some plain text to ciphertext is called encryption, and converting the ciphertext to plain text we call as a decryption here. Is that clear, everyone? Right. So here again, encryption is again encryption having the two types. That is symmetric encryption or symmetric encryption or asymmetric encryption scenarios. Just give me a second. Right. So we have again the types of encryptions here. Okay, one is symmetric, another one is asymmetric. So can anyone know the difference of these two, the symmetric and asymmetric thing? Again, there are two types of cryptography. So cryptography is categorized into two types according to the number of keys employed by the encryption and decryption here. So in that, we have asymmetric encryption and symmetric encryption. So asymmetric encryption is nothing but where it requires both the sender and it is having the same key for sending and receiving the data. Okay, so we use a same key, means only single key we use to encrypt and decrypt your data. Okay, so like the sender uses the key to encrypt the plain text and sends the key to the ciphertext to the recipient. So who uses the same key, which is used for the encryption, uses the same key to decrypt the ciphertext into a plain text, means to convert. So simple, to encrypt this. So this is a plain text. So again, to make it to cipher, I'm using a key and making into ciphertext. Okay, so making into ciphertext here, right? And converting a cipher. For example, I go here, we go in detail. Imagine my This is the plain text. So the message is some hello. Hello is my data here. So now I'm using a key. So the key can be any key here. Maybe the key is generated based on the algorithm here. They use the algorithm as I mentioned you. They use some algorithms here, and that algorithms will generate a key for you. So which converts the cipher, which make it to the cipher. Now, once the key using the cipher and it generates a cipher text, which is nothing but. So will you able to understand this? So converting into some unreadable format. So this is the encryption side. This is what encryption they made. Okay, so the plain text using the key, they make into the ciphertext. Okay, and now same process can be done using the same key, whatever the key I'm using here, whatever the key I used here, the key as sent through the ciphertext and received by the recipient. The recipient will receive the data in ciphertext. We receive the data in ciphertext, which is nothing but like ID, ESD is the ciphertext. And using the same key, whatever the key we used here, use the same key, the cipher, now will be decrypted into plain text, which is hello. So this is what happened here. So this process we called as a decryption. So if you observe here, yeah, it's a public key and it will be the both sides. So means for encryption and decryption, we use the same here. Example, I can take the example of symmetric keys, your Wi-Fi passwords, uh, or the symmetric key scenario. So I can tell you the password, right? So now you will enter that password and it will authenticate and it will give me same password, same key. I'm sharing with the other guy and he's using that and he's able to connect with that network. So that is what the symmetric scenario. So the main disadvantage with this symmetric is, I don't know who is sharing that. For example, if that key got compromised or taken by any other person, they can able to access to this data. So whatever the data is encrypted, they can easily access to data. Why? Because they use the same key for encrypting and decrypting. So it is a bit difficult for us to identify who breached the data, who breached the data here. Got my point? So for encryption and decryption, they use the same key. Example, you can take your Wi-Fi authentication. So just I'm typing the Wi-Fi password here and I'm able to authenticate with that and I got. So if I got that Wi-Fi password, so along with that data it contains the key. So obviously I can connect with that particular network. So if anyone knows that key, easily they can able to access to that service. Got my point? Is that clear? Is that clear, everyone? So remember, in symmetric, we use the same key here for encryption and decryption. Okay. So this type of cryptography works well when you are communicating with only few people, because the sender and receiver must share the key before sending any messages. So this technique is of limited use for the internet. So where individuals who have not had a prior contact frequently require a secure means of communication. So the solution to this problem is asymmetric. So in asymmetric, how the communication will happen is it uses two keys. Okay. So when it comes, is that clear for everyone? Symmetric. So for encryption and decryption, they use the same key. Okay, and there is easy to breach. So you can only implement this symmetric with the few limited people. You can't go with everyone in public places. Okay, clear everyone? The symmetric. So when it comes to the asymmetric, here we use two keys or two or more keys here. Right. So one is public key and another one is private key. All right. So in this scenario, how the communication example you can take for symmetric is your emails. Emails use asymmetric only. So for example, let me take the plain text. Okay. So message is hello, I want to send. So now I want to send a mail. So first what I need, public key. So public key is nothing but the receiver key. Okay, like is mail ID. And now I'm converting into some cipher. Okay, now I'm using my private key to make it cipher text. Again to another cipher. Right. Then making it to ciphertext, which is nothing but the data here, something. Okay. So now here I'm using two keys to make the data cipher. Okay, this is completely encryption side. So now I want to send a data to this a person. So I'm taking his mail ID and I'm authenticating with my password and I'm making it to the ciphertext. Now key ciphertext. So this is a ciphertext. Again, the guy who is receiving the data, he need to use his private key, means his password, and decipher. Now it will be converted into plain text, which is hello. So you can see here. So the public key of, for example, here take this is Akhil here, and here we have Pawan or sorry, Praveen we have. So let me take the Praveen, and here Praveen use his private key and use the Akhil's public key. So previously, if you see, while encrypting, Akhil is having the email of Praveen. Akhil is having the email of Praveen, and he wants to send the mail to the Praveen. So what he is doing, he is using the mail and is sending the mail by authenticating himself by giving his credentials or the passwords and authenticating with the email and typing the message and sending that. Okay. And to receive or see that mail, again, Praveen is logging into his account and checking for the person who sent the mail, Akhil mail ID. Now he got to know that means he knows that the mail was sent by the Akhil itself by authenticating. See, again, here he is using his mail ID and checking for the Akhil, and here Akhil is using his password and checking for the Praveen. So on that basis, the data has been exchanged and converted from the plain text to ciphertext. So here the conversion is taken with the help of two keys. So the concept of asymmetric encryption is also known as public key cryptography. So it was introduced to solve the key management problems. So this encryption involves both a public key and private key, and the public key is publicly available, whereas the sender keeps the private key and sends the data. So as an asymmetric key system, it is an encryption method that uses a key pair comprising a public key available to anyone and private key held only by the key owners. So which helps to provide the confidentiality, integrity, authenticity, and even non-repudiation in data management by implementing this symmetric key. Is that clear? So here it is using two keys. One key is for encryption and one key is for decryption. So they use two keys here. Got it? Is that clear, everyone? Say something. Is that clear, everyone? Sorry there. Right. So in encryption, we have in cryptography, we have types of cryptography. One is symmetric cryptography or symmetric encryption, and another one is asymmetric encryption. So where symmetric encryption use the same key for encryption and decryption, and asymmetric key use two keys for encryption and decryption, which is public key and private key. Right. And here it is easy to identify from where the data breach happened, from which end the data breach happened here. But here it is a bit difficult for us to understand from which end the data breach happened. Why? Because the two keys are with the two people. Right. But here individually they're using the keys, so easily we can identify from which end it got data breach. Clear, everyone? That is what the cryptography is. Right. And there is a GK concept called governance access to the keys. Means some companies what they do is when they want the investigation, when they want to investigation the particular company, so at the time they have to share the data, right? So for example, if I want to tap, now the hot topic in the Telangana state is the phone tapping scenarios, right? So to tap that, actually they have to get the permission from the government, and they'll monitor these people. So at the time, these telecommunication service providers should give the access to these intelligence people, right? But here, without their permission, they got, that comes under the illegal activity. So there will be some terms and conditions in this scenario. So where the companies will give a copies of keys, means not all the keys, a sufficient keys they will provide here to the law enforcement people. Okay, so that concept, that scenario we called as a GAK, which is nothing but government access to keys. That is what the scenario. So GAK means that software companies will give a copies of all keys, or at least a sufficient portion of each key that are the remainder could be cracked to the government. So the government promises that they will hold on to the keys in a secure manner and will only use them when a court issues a warranty or a permission to do so. So to the government, this is similar to the ability to wiretapping the phones like that, right? So law enforcement agencies around the world acquire and uses these cryptographic keys to monitor the suspicious communications and collect the evidence of cyber crimes in the interest of national security. So on that portion, the software companies or the other companies should provide some access to the government sectors, like for example, for the department. So where they can able to monitor these cyber criminals to find the suspicious activities or to prevent from that particular attacks. So at the time, the companies should give the access to that particular data. So on the mutual understanding, the companies will provide some certain amount of access to these government sector people. That is what the GAK scenario is. Got it? Right. So the government promises that it will hold the keys in a secure manner and only use them when court give the permission for them. So to the government, this issue is similar to the ability to the wiretapping the phones. And government agencies often use the key escrow for uninterrupted access to the keys. So key escrows is a key exchange agreement in which essential cryptographic keys are stored with the third parties in escrow. So the third party can use or allow other to use the encryption keys under the certain predefined circumstances. And the third parties with regard to the GAK is generally a government agency where that many use the encryption keys to decipher the digital evidences under the authorization or warranty from the court of law, get the permission from them. Right. So that is how they access to these confidential data by mutual understanding with the companies. Now you can see here, the keys can be shared. So items which the GAK has right to access and the items to which GAK has no right to access. So only limited services they'll provide by the companies to the law enforcement. All right. Clear, everyone? Right. So this is the government-based scenario. So coming back to the encryption scenario. So we have different types of symmetric encryptions and asymmetric encryptions. So when it comes to the symmetric encryption, so as you know, encryption is a process of converting the plain text into a ciphertext using a set of complex algorithms where that transforms the data into the blocks or streams of random alphanumeric characters here, right? So there are many different types of encryption algorithms we have. So some of the encryption algorithms for symmetric basis like AES, DES, right? And what else we have? AES, DES, 3DES, RC4, 3DES, RC, RC4 now we use. Actually, you can see RC4 we used in WEP in Wi-Fi. If you remember, WEP, a wireless encryption standard we have, right? In that they use RC4 only. And AES, you can see that is used in WPA2. Whatever the encryption standard we use, they use the WPA2. So these are the some example for the symmetric base. Symmetric. And there are some other encryption algorithm for asymmetric scenario. One of the popular encryption algorithm is RSA. RSA and what else we have? Diffie-Hellman. You may have heard about this. DH. Diffie-Hellman. And what am I missing? Diffie-Hellman algorithm and eclipsed kind of thing will be there. So eclipsed thing will be there. And what I'm missing? DES, DES. ECC will be there, which is nothing but elliptic curve cryptography. This is another one. And even DSA, which is nothing but a digital signature algorithm. So these are the asymmetric based. So these are the encryption types of encryption in symmetric and types of encryptions in asymmetric we have. So like that, using these asymmetric and symmetric, we encrypt the data. So as you know, as I mentioned you, that we use different types of algorithms here, and each algorithm has their own functionalities here, right? And encryption means converting the plain text to ciphertext. So when it comes to the ciphers, so what are the ciphers? What are the ciphers? So cipher is an algorithm here. It is an algorithm or a series of well-defined steps. Algorithm is nothing but, it's a step-by-step instruction. So it is a algorithm for performing the encryption and decryption. So in cryptography, a cipher is an algorithm for performing the encryption and decryption. And encipherment, we call this as an encipherment. So encipherment is nothing but it is a process of converting the plain text into a cipher or code. And the reverse process is called decipherment. It is a process of converting the plain text to cipher or a code is called encipherment. And decipherment is nothing but here converting this cipher text. Again, it is a process of means it's a process of converting. Means the reverse process of encipherment is called decipherment, which is a process of converting the ciphertext or code to the plain text. So a message encrypted using a cipher is rendered unreadable unless it recipient knows the secret key, and which is required to decrypt it. So the communication technologies like your internet and cell phones, the cell phones or telecommunications rely on the ciphers. Why? Because to maintain both the security and privacy. Now, getting my point? So communication technologies like your internet or cell phone relies on the cipher to maintain the both security and privacy here. So these cipher algorithms may be a open source, and the algorithm like this algorithm process is in public domain, while the key is selected by the user and is privated also, or a closed source also means the process is developed for the use in specific domains, such as like your military sectors only. So algorithm itself is not the public domain here. So ciphers may be free for public use, or it may be a licensed one. Anything it may be, right? And here we have different types of ciphers. There is modern ciphers, there is classical ciphers. So when it comes to the modern ciphers, it will be private key and public key scenarios based on the type of input data what we give, which is block cipher or steam ciphers. So there are some block ciphers. So you can note down, see what is the block ciphers, what is the steam ciphers, and what is this transaction cipher or transposition cipher, right? So these are the different types of ciphers we have. Go with the difference between. So there will be a classical ciphers and modern ciphers. So classical ciphers are related to your symmetric and asymmetric. When it comes to the modern ciphers are based on the types of keys which we used. And when it comes to the classical cipher, there will be a substitution ciphers, substitution ciphers, or transposition ciphers, right? And when it comes to the modern, we have the block ciphers and steam ciphers. This is how the data will be converted according to your cipher basis on steam ciphers. Okay, so can just go with these types of ciphers here. Okay. So that is how the things work here. So as you know, decipherment and encipherment, which converts the data from plain text to ciphertext and ciphertext to plain text. So, for example, when it comes to this steam ciphers or substitutional ciphers, you see we have substitutional ciphers also. So we call this as a classical ciphers, and these things are the modern ciphers. So classical ciphers are the most basic type of ciphers, means which operates on the letters of the alphabet from A to Z. So these ciphers are generally implemented either by hand or with simple mechanical devices, right? So you can see Enigma devices will be their machines, so which are used in World War II. So which encrypt the data, and forward the message secretly to the military. From commanders to the military, they communicated through this Enigma machine only. So at the time, so that generates the cryptographic concept here. So at the time, they use this classical ciphers. So for example, there is a substitutional cipher. So let me take this hello. So this is a message. So let me take A, B, C, D, E, F, G, H, I, J. So imagine these are the alphabets we have, which are from A to Z here. Right. So this can be converted, means it replaces the weather. For example, let me take the substitutional cipher. So the user replaces the units of plain text with ciphertext according to the regular system. Means the units may be a single letters or pair of letters or combinations of them. Okay, so the recipient performs the inverse substitution to decipher the text, like a Bailey ciphers or auto key ciphers or Groenfield ciphers or Hill ciphers, like that. They use some cipher technology here. So if I use a key as 3 here, key has 3. That means after H, 1, 2, 3. So it replaces with the K. And let me go with E. E replace with H. L. So L replace with O. And again O. And O replaces with R, like that. Means the key is 3. So where it replaces with the 3 bits of alphabets here. Right? This is a kind of a classical ciphers. So as I mentioned, which operates on the letters of the alphabets from A to Z. So as I mentioned, these ciphers are generally implemented either by the hand or with simple mechanical devices, because these ciphers are easily deciphered. They are generally unreliable here. The classical ciphers are. Okay. So like that, we have the transposition ciphers also. So here the letters in the plain text are rearranged according to the regular system to produce the ciphertext. So same like hello you can take. So when you encrypt that, that will be fine. So they use for classical ciphers, some of the cipher algorithms are rail fines ciphers, root ciphers, right? And Bales or ciphers. There are many different mechanisms they use here with the different key sizes. Okay, so I can give you a website here. It's T-code. There will be a website actually. You can easily identify them. I have bookmark. Use this website for you as a reference here. So I'm sharing this in the chat box also. So where you can find or analyze the cryptography things. So you can see. So there is a cryptography thing in that you can see the cryptanalysis, means cipher identified or bigrams, their frequency analysis. You can do all these things, and you can see the modern cryptography. So which is using this RC4, SHA, MD5 hashing scenarios, Diffie-Hellman key exchange. All it's include all the thing. So you can see the substitutional ciphers. So you can see these are all the different types of substitutional ciphers and transposition ciphers, polymorphic ciphers. So like that, you can see the different types of ciphers, and these ciphers are using a different algorithms or different programming services. So it generates the key, right? So here you have the cipher identifier. So whenever you find any cipher, you can give that, it will analyze and it will give the output for you, right? So that is how the things work here. Okay, so but the best sources I'm giving for you. So what is the cipher identifier? it gives like it will explain you about that particular thing, what it do also. Got it? So I have given that link in the chat box, so you can go through that. So you have polyalphabetic transposition ciphers, right? So let me take rail fence. So automatically it will generate a cipher for that. So zigzag scenario, it will be in zigzag scenarios. It will generate like left or top or left top or bottom left, whatever it may be, it will convert that accordingly. So you can make it into different format, right? So these are some classical ciphers. So you can see rail fence is also known as zigzag. So it is a transposition cipher consisting to write a text in zigzag and reading it in a straight line. Okay. So you can see as an example, they have given like some encryption decode with the n number, means it replaces the number with that particular alphabet. Just now we did for the hello, same. It will make that, and it will be making it in zigzag position. Okay. So we have Caesar cipher. It is also kind of a like modern based ciphers. It is right. So I think that I mentioned the Caesar cipher. Huh? So you can see Caesar cipher. So it's in substitutional basis of it. So it is a mono alphabetic substitution. Okay. So where each letter is replaced by the another letter located in a letter fusor. That is what we did. Same like your right to left or left to right. Here I did it from right side. So there you can make it to left side and right side both the way. Right. So you can see Caesar cipher. So it's a plain text. You can see alphabets, and it use a key like same. We did for hello, right? That is a Caesar cipher only. It comes under the substitutional part, not modern. Sorry, it's a substitutional based ciphers only. So where it replaces with the D. So you can see A, B, C, and it replaced with the D. So as a three position here, they mention as a three position. So as a three position, it replaced with that. B is replacing with E, C is replacing with F, D is replacing with H, and Z is replacing with C. So like that. So the encrypted D takes the alphabet and look at the three characters and go with the G. So D is the encrypted with the G. That is how the things work. So like that for everything here, you have an explanation. So you can go through that website. Can we change the position of Caesar cipher? Yeah, it depends on the key what you have given. So there I'm mentioning as a 3. So what if I'm mentioning as a 5? It replaces with the 5th character. Got my point? Example. Cipher. So here I'm mentioning the key as 5, and I'm going with alphabet A. So let me decrypt. Right. So it is replacing with the character 5. So 5 is replaced with the 5th character. Got my point? So if it is 1, it is replacing with B. So you can give your own key here, the shift or key number. So accordingly, it will generate from 0 to 9 alphabets you want, you can go with that. If you want to go with 23 characters and with another things, or only ASCII table basis or customized alphabet, you can make it. You can make it accordingly. Got my point? Right. So it replaces with F. A is replacing with F scenario according to the 5th key. So it depends. You can give that. You can change the position. So that depends on complete the code. So they are easily crackable, you know. So if you analyze that, you can easily crack them, right? So like that, there are different types of ciphers you can see in this, right? So there is a substitutional ciphers and this transposition ciphers, right? So and even modern ciphers are designed to withstand a wide range of attacks. So to provide a message secrecy, integrity, and authentication of the sender. So a user can calculate a modern cipher using a one-way mathematical function that is capable of factoring the large prime numbers, and they can modify that. So as I mentioned, when it comes to the modern ciphers, so here it includes with the authentication of the keys. Means the secret keys should be shared between the sender and receiver, or they can use two keys to authenticate that particular service. But here, no need of any exchanging of the keys. So where it will easily decrypted according to the key size, right? So modern ciphers only we are using. So based on the type of keys we used and based on the type of input data we are giving, according to the modern cipher, it will be converted. So when it comes to the block cipher here, uh, it is a algorithm which operating a block, means a group of bits of a fixed size with a unvarying transformation specified by a symmetric key. So most of the modern ciphers are block ciphers only. Most of the modern ciphers will be the block ciphers only. Why? Because they are widely used to encrypt the bulk data. Bulk data can be easily encrypted by these. So your DES, AES, IDEA, all these things use the block ciphers only. So when a block size is less than that used by the cipher, padding is employed to achieve a fixed block size here. And when it comes to the stream size, so combined with a key stream, the user applies the key to each bit one at a time. So that will be implemented in your RC4 or SCL. All these encryptions, they use the stream cipher. But most of the ciphers or encryption algorithms use the block ciphers only. So they completely provide the key for the entire data. So if it is a complete bulk data, they can provide the key. Or individually, each block basis, how much data you are maintaining for each block also, they can make the key. So that is what they can provide the key in the block ciphers. Okay. Yeah. So these are the some different types of ciphers we have. Go with the modern cipher and classical ciphers. And coming back to the encryptions, as you know, we have different types of encryptions here. One is symmetric and asymmetric. So in symmetric, if you go with that, we have DES, 3DES, AES, RC4, can go with the blowfish, or you can go with the two fish, or you can go with the what you can say, there is another one called TEA, T-based one also we have. So like that, there are many symmetric algorithms you can see. So most probably we use for the latest thing is your AES. The advanced one we are using for this symmetric basis, AES only. You may have seen these things in many places, like in Wi-Fi passwords, the authentication will be happen with AES encryption only. If you observe, right? So you can see that WPA2 they use AES scenario. Right. So what's the difference of these is their block size and key size. This will be the difference of the block key size and normal data size will be defined here. So it comes to the DES. So it is data encryption standard we called. DES is nothing but here data encryption standard. Okay. So it uses a secret key for both encryption and decryption. Why? Because as you know, it's a symmetric based algorithm. It's a symmetric cryptography. Okay. And DES use 64-bit secret key, of which 56 bits were generated for randomly and 8 bits are used for error detection. So in this only at the end, it will generate the 66 bit of key, and in that 8 bits are for error detection they use. Okay. So it generate a 64 bits of secret key. So DES and AES is useful in information security. Exactly. Right. So as you know, DES uses a 64-bit secret key. In that, 56 bits are generated randomly and 8 bits are used for error detection. and it uses a DEA, which is nothing but the data encryption algorithm, DEA, a secret key block cipher employing a 56-bit of key operating on 64-bit of blocks. And DES is the architectural block cipher, and it is an algorithm that takes a fixed length string of plain text bits and transforms it into a cipher text bits, right? So the design of DES allows the user to implement it in hardware and uses it for a single use encryption. So such as to store the files on hard disk, will encrypt that hard disk, right? So at the time they use DES. Okay. So DES provides around 72 quadrillion or more possible encryption keys and chooses a random key for encryption of each message. Because of hierarchical weakness of DES, today's technology, some organizations use triple DES. So there is a bit insecurity of DES. So they implement the 3DS, means three times it convert the key. 3 times it will convert the key. So which repeated the process 3 times for adding the strength until they can afford to update their equipment to AES capabilities. So 3 times of DES process. That is what triple data encryption standard do. So 3DS is nothing but a triple data encryption standard. So it become obvious that DS would no longer be secure. So the US federal government began a constant seeking a replacement cryptography algorithm. That is what DES. So in the meantime, 3DS was created as an interim solution. So it performs DES 3 times with the 3 different keys. And it uses a key bundle that comprises 3 DES keys, K1, K2, and K3. And each key is standard 56 bits of DES key. So it then performs the process of following the data, right? And when it comes to the AES, which is nothing but advanced encryption standard. So again, it is a National Institute of Standard and Technology specification for the encryption of electronic data. Okay. And it has a bit size of 128 bits. Okay. So AES consists of symmetric key algorithm, means both encryption and decryptions are performed using the same key. So it is iterated block cipher, and that works by repeating the defined steps multiple times. And it has 128-bit block size with the key size of 128. It's 128-bit of block size, and 128, 192, and 256 bits of key size. Okay, to encrypt that, they use the 256-bit of key size. So we call that as a AES 128, AES 192, or AES 256 respectively. So the design of AES makes it use efficient in both the software and hardware. And it works simultaneously at multiple network layers. So that is how the powerful of AES. Okay, and you can see the size of the block is 128-bit, and the size of the keys is generating is 128, 192, and 256 bits of key sizes it is generating. So that is what we called as a AES 128, AES 192, and AES 256, which is having a key size accordingly. Okay, clear? So that is what AES scenario. And as you know, it was implemented by the NIST, which is National Institute of Standards and Technology. So it also helps to encrypt the digital information such as your telecommunications, financial, and even your government data. So US government agencies have been using it to secure their sensitive but unclassified material. Okay, that is what AES. And next we have RC4. And not only RC4, we have, which we call as a reviset cipher, which is nothing but RC4, RC5, and RC6 will be there. and they use some algorithms which are performed by some operators, XOR operators or add-on operators, NOR operators, like that. They use these operators and they make it or they generate the algorithm here. So when it comes to the RC4, it is a variable key size of symmetric key cipher, which is using the Steam cipher here with the byte-oriented operations, and it is based on the use of the random permutations. Random permutations generate the key here. So most of the time you can see RC4 in SSL certificates. Okay, so RC4 enables the communication such as the traffic encryption, which secures the websites. And for websites that uses the SSL protocol, they implement the RC4 on it. So it is a variable key size symmetric key stream cipher with the byte-oriented operations, and it is based on the use of random permutations. So according to some analysis, the period of the cipher is likely to be greater than 10,000, right? And each output byte uses the 8 or 16 system operations here. So the cipher can run fast when you used in software. Okay. And we have RC5 also, which is a fast symmetric block cipher design by the Ronald Riveset for RSA data security. So the algorithm is a parameterized algorithm with a variable block size and a variable key size and a variable number of rounds also. So where the block size can be around some 32 bit or 64 bit or 128 bit in that particular RC5. And the range of rounds can be varied from 0 to 255 here. And the size of the key can be varied from 0 to 1024, 2040 bits like that. Not 1024, it's 2040, means around 2 MB bits of data. So this built-in variabilities can often flexibility at all level of securities here, right? So they use this bitwise or XOR or variable rotations here, or integer additions like that they implement in there. Okay, so that is what RC5 like that. We have RC4, which is derived from the RC5 itself, and it is having the size of 128 bits with the block cipher of AES, right? So like that we have RC4, RC5, and RC6. So mostly we use RC4 to implement the data here, but again it's a low level of security it provides. And next we have the blowfish. So it is a type of symmetric algorithm again, which is designed to replace. Mostly this particular algorithm is designed to replace the DES or IDES. So it uses the same secret key to encrypt the data and decrypt the data. And these algorithms splits the data into block length of 64 bits. It is having the block length of 64 bits. And it produces a key ranging from 32 bits to 448 bits of key size. Key size it generates. Here it generates the block size. Okay. And due to its high speed and overall efficiency, blowfish is used in software ranging from password protection tools to e-commerce websites for securing their payment gateways. Most of the payment gateways, they use the blowfish services. So it is a 16-round fichial cipher working on 64 bit of blocks. So however, DES, its key size range is around some 32 bits to 448 bits. So these algorithms has two parts. The first part handles the expansion of the key, and the second part handles the actual encryption data. Okay, and the key expansion is handled in several steps. So the first step is to break the original key into a set of subkeys, and especially a key is no more than 448 bits is separated, and there is a P array which is 4 bytes of 32-bit boxes. Here it will be implemented. So like that, they use some algorithms, the permutations here, where to generate a key, a encrypted key. Okay, and using that key only we can able to so as you know, they use the same key for encryption and decryption in this. And we have twofish. So twofish is a kind of algorithm, so which was one of the US government's 5 finalists to replace the DES. So twofish algorithm was one of the US government's 5 finalists to replace the DES, but it was replaced with the RC, like especially with this RC4 itself or Blowfish itself. And it was not chosen actually. So they used a chosen of Blowfish, and it was designed by the Johnny and Whitening and David Wanger or Chris Hall. Like that, there are many people who involved to build this particular algorithm, and it is a 128-bit of block cipher. It is generating a 128-bit of a block cipher here. Okay, and it is one of the most conceptual simple algorithm where that uses a single key for both the encryption and decryption for a length of 256 bits here. Okay, and this technique is enabling the different implementations, improving the relative performance of the algorithm, and any user can optimize the performance based on the key scheduling using this two-fish algorithm. Okay, and there is a three-fish also. So it was developed in 2008, and it is a part of Sikin algorithm. It is a part of Sikin algorithm actually. So it was enrolled in NISTs, which is National Institute of Standards and Technology, with the concept of hashing based, means it involved with the hashing also. So it is a large pickable symmetric key block cipher in which the block and key size are equal. So that is 256 and 512 and 1024, which is more secure than your AES2. So three fish involves only three operations. One is additional rotation, XOR operation. So which makes the coding simple, and all these three operations work on 64-bit words. So the three fish block size is around 1024. So these are the key size. Sorry, it's a block size that can generate around 256, 512, and 1024 block sizes here to generate a key. So this algorithm does not support or does not use the Xboxes to prevent the cache timing attacks here, right? So like that, we have different types of encryptions you can see in the three fish scenarios. Okay, and then we have the TEA scenario, which is nothing but tiny encryption algorithm. It's tiny encryption algorithm. So which was created by the a David Wheeler, and it was publicly presented for the first time in 1994. So it's a tiny encryption algorithm. It is implemented in 1994, and it is a simple algorithm, and it is easy to implement in code also. Why? Because it is using a Fisher cipher that uses the 64 rounds. Just a second. Yeah, it uses official ciphers actually. So you can go through this official ciphers also, which includes the XOR operations and rounds will be there. It means it completely implement a fewer or more rounds to encrypt the data and generate a key size here, right? And when it comes to the encryption part, it generates around 64-bit of block size and 128-bit of key size in TEA. So TEA uses the 128-bit of block size and 128-bit of key size and 64-bit of block size. That is what it can generate: 128-bit of key size and 64-bit of block size, where to generate the cipher text, right? So like that, you can see the VAT between these algorithms is their key size and their block size. As simple. And algorithms which they implemented to generate that particular thing. right? And when it comes to the asymmetric basis, so the one of the powerful encryption we use in the asymmetric based algorithm is RSA. So I don't know how many of you are aware of the RSA algorithm. So RSA is nothing but R is nothing but here Ron reset, and S is nothing but Adi Shemer, the three scientists name here actually, and A is nothing but Leonard Adelman. So reset, Shamir, and Adelman is the name of RSA actually. So formulated as RSA. So it is a public key crypto system for internet encryption and authentication. So RSS use the modular arithmetic. They use a modular arithmetic and elementary number theories. They use theories actually. So completely involved with the mathematical part. So its RSA is a public key, a crypto system for internet encryption and authentication. So it uses a modular arithmetic and elementary number theories to perform the computationals using two large prime numbers. So this system is widely used in a variety of products, platforms, and industries. It is one of the de facto encryption standard. Remember. So many companies such as your Microsoft, Apple, Sun, Novell build, all these people build the RSA algorithms into their operating systems. So RSA can also be found on hardware secured telephones, Ethernet networks cards, which is nothing but your NSCs, and even in your smart cards also. And even they implemented to your connection, secure connections, whatever you're seeing here. So it was implemented using. So if you see the security in that, they have the certificates. So these certificates also included with the RSA. So can you see the public key info? They're using the RSA along with the SHA encryption, which is nothing but the hashing scenarios. So secure signature, they're generating the signature algorithm with the help of SHA, which is simple hashing algorithm with RSA encryption. It includes the both here. So most of the sites or digital certificates, they use this RSA only, right? So even in your hardware secured devices also, they use this RSA, like your telephones, Ethernet cables, your smart cards, all they are implemented with the RSA only. And these RSA build an algorithm with the help of the modular arithmetic and elementary number theories. Got it? Is that clear, everyone? Right. And next you have the like Diffie-Hellman. It is also kind of a asymmetric algorithm. So it is also kind of a asymmetric algorithm where that allows the two parties to establish a shared key over a insecure channel. And it was developed and published by the Whitefield Diffie. There are two people here. Again, their names only involved here. And Martin Hellman. So Diffie-Hellman is the algorithm they implemented. It was in 1976. So actually, it was independently developed a few years early by the Macklem J. Williamson of the British Intelligence Service, but it was classified at that time. So that was implemented and developed by these two people again. And they also used the perminator, parameters with the prime numbers, and generated this algorithm. And it does not provide any authentication for the key exchange, and it is vulnerable for many cryptographic attacks. That's why they mostly don't implement these Diffie algorithm. So as you know, in this they go with this RSA and RSA only most of the time, right? So like that we have different types of algorithms here. And when it comes to the hashing, so what is hashing here? So till now we have seen the encryptions and decryptions with their algorithms. You can see the symmetric encryption and asymmetric encryption, and we have seen their different algorithms which generate the keys there. But when it comes to the hashing, so what is hashing here? So what is the difference between the encryption and the hashing here? Anyone having any idea? You know that we discussed about that hashing at the beginning time. Like we have seen different hashing algorithms, right? Like MD5, MD456, like that we have algorithms. And we have another one is SHA. So MD is nothing but here a message set, and which is SHA is nothing but here secure hashing algorithm. Secure hashing algorithm. Okay. So hashing is nothing but here one-way function. Here it is a two-way function. But when it comes to the hashing, it is a one-way function. So hashing, why I'm saying one-way function in the sense, it generate a constant string value here. A fixed size bit string value will be generated here. Okay. And you can't reverse them. Means there you can encrypt and you can decrypt using the key. But when it comes to the hashing, there won't be reversing that hash. It's a one-way function. So hash functions calculate a Unix fixed size bit string representation called the MD, which is message set. Okay, so it is a function which distill the information contained in a file into a single fixed length number. So as I shown you previously, like a hash decryptors will be there. So website actually. So there is a codebeauty.org website. You can go to this website and you can search for the MD5. You can see there are different types of hash generators. Can you see MD2, MD4, MD5, NTLM hash, as you know, we use in sham file in authentication, SHA-1, SHA-2, SHA-3, which is SHA-3, 84, 512, the combination of this board. So you can see, you can give a file or you can generate a thing also here. So let me go with some, hey, what's up? So can you see generated a constant string value for this particular data? What if I remove the cat? Can you see, is the data changing? And if I skew the space, is the data changing? Whatever the changes I do, the key is changing automatically. So easily we can implement this for the integrity part. Means to avoid from any unauthorized changes. So even it may be it may be to a file, or it may be even if in a file, if you do any changes to the data, that will be change the value of that. So easily we can identify the unauthorized changes to the data by implementing these hashing. Is that clear? So for that, we use a different types of hashing mechanisms here. Got it? So hashing is a one-way function, as you know. So it generates a different types of algorithm. Means it generates the fixed size length of the data by using these different types of algorithms here. So as I mentioned, hashing. So a hash function is a mathematical function where that takes an input or a message and produce a fixed size string of characters here. So which is typically a sequence of numbers and letters. So the output knows as the hash value or hash code, so which is a unique to the input data. And hash functions are commonly used in cryptography to ensure the, what is the use of this? It ensures the data integrity and security. That is what the use of this hashing. Okay. So it gives the same input as the hash functions, will always produce the same output there. And hash function produce a fixed size output regardless to the input size. And it is the computational inflexible to the determine the input data from the hash value. And it is extremely unlike for two different inputs to produce the same hash value. So you won't get any same hash value for two different inputs. Remember. So it will generate a unique hash value for every time. And a small change in the input data should produce a significant change in the hash value. A small change in the input data will produce a significant change in the hash value. Right? So applications of the hash functions are like your password storage. So like hash functions are used to securely store your passwords by hashing. So you can see mostly we use this in the applications like password storages. So as you know, yeah, you can generate that. There are many hash generators we have. You can generate them. But manual in the sense you need to write that code there. Again, what length should be generated, what is the key size of that value. Like you need to go with these things. Again, it includes the algorithms. Again, this hashing also includes with the algorithm. MD5 is an algorithm only here. SHA is also algorithm only. They generate with the key, which implemented with the mathematical part again. All right. So applications of these hash functions are like password storage, means where the hashes are stored to securely store your user passwords by hashing them and storing them in the hash values instead of actual passwords. As you've seen, do you remember these guys? SAM file. Your Windows will have the SAM file, and your Kali will have the password path, etc password. Do you remember them? SAM file, you heard her. Man, I have given task also. We did that. We extracted that with the Metapreter session. You heard her. I've shown you the SAM file, right? So this is a SAM file. The administrator is the username. Can you see? Your password is storing in the hash format. So it is hash format will be there. So where we use that hash for the password storages and even for the data integrity. Just now I have shown you. So when you change any data value, it gives a significant change in the hash value also. So that is what the data integrity. So hash functions are used to verify the integrity of data by comparing the hash value of the received data with the original hash values. And we have the digital signatures. So in digital signatures also they use this hash. So digital signatures. So where hash functions are used in digital signature to ensure the authenticity and integrity of the data or digital documents. And even your blockchain system or blockchain technologies also they use this hashing. Blockchain. So blockchain technology also they use this hashing on. Got it? Right. So we have two types of hashings here. One is MD5 or message digit. Okay, so it is an algorithm that takes a message of abbreviated length as the input, and then it produces the output of 128-bit of a fingerprint or a message digit as the output. So MD5 is not a collision resistant. So use of the latest algorithms such as MD6 or SHA-2 or SHA-3 or or MD6 scenarios. So why? Because there is a chance in collision part in MD5. So that is why I go with the SHA. So in SHA we have SHA. I think it's 250, 512, SHA-1, SHA-2, and SHA-3 will be there. SHA-1 is nothing but it is around some 160 bit of hash function it will generate. So it is implemented and published in 1993. So yeah, 93, and it mostly used in TLS and SSL services or SSH services also they used. So it is most commonly used in security protocols such as PGP or TLS and SSLs they use, the SHA-1. And it generates around 160 bit of digiset from a message with a maximum length of 264 to 264 bit of length it will generate. So, and it was generated by the NSA, National Security Agencies. So to be part of digital signature algorithm DSA, and it is most commonly used in PGP, TLS, and SSL. And SHA-1 is no longer approved for the cryptographic use because of its cryptographic weaknesses. They are not using that, and they moved on to this SHA-2, which is nothing but we call this as a SHA-256. SHA-2 is nothing but SHA-256. SHA-3 is nothing but 512. So SHA-2 is a family of two similar hash functions with different block size, namely SHA-256, which uses the 32 bits of length in that generation, and SHA-512, which uses the 64 bit of words. And they have the SHA-224 and 338 also. So they use this XOR into the initial bits of the stage where they make the block size with the permittivities, right? And its internal structure considerable from the rest of the SHA family, right? So that is what SHA-3. Okay. So like that, we have different types of hashing algorithms. Like we have HMAC also. So HMAC is nothing but hash-based HMAC, which is nothing but hash-based message authentication code. Hash-based message authentication code. So it is also type of message authentication code, MAC, where that uses a cryptographic key along with the cryptographic hash function, and it is widely used to verify the integrity of data and authentication of message. So these algorithms includes an embedded hash function. Okay, so you can go through this HMAC also, and you have EAP. So EAP will be there, which is nothing but extensible authentication protocol. So it is also an authentication protocol that was originally designed for point-to-point connection, and it is used as an alternative to the uh, challenge handshake authentication protocol. So which is a mechanism used for the point-to-point protocol. So mostly they use in authentication parts. Okay, so like that you can go through this hashing thing and see what they are. All right. Today topic's name. So it came very early. Yeah. All right. So just go through these things. So see what is the encryption and hashing differences. So most of the time they'll go with that part, right? So see, I need the difference of encryption and hashing, and see go with what is PKI, which is public key infrastructure. Okay, see what they are, and what else? Go with these signatures and see what is technography. So have you heard about this technography? I told you on system hacking basis. They'll embed it into the systems. Yeah, using the image, they'll find the data. Go with this technography. So this will be the task. This is a session today. So go with the topics, everyone. I'm going to share the task document. Mhm. So I have shared the document in the chat. So make sure you can download that and go through that concept. Okay. So this is what the cryptography, so which includes the encryption, the types of encryptions, their algorithms, and hashing and digital signatures. So this is how the things work. So there are many hash generator tools and uh, what you can say this uh, services you can find it from online. Okay. So just see about the cryptanalysis also. So what is cryptanalysis? How the cryptanalysis will work? For that, what the things are required? How much knowledge should be there in this thing? Like in mathematical part, how the algorithms will be generated? Just check that. Okay, is that clear, everyone? So I think we left with two more sessions. I'll go with the web application and penetration testing as an introduction. I'll go with some introduction thing. I'll give you the introduction about the what is this penetration testing, what are these applications, what is the approach methodologies we have in web application pen testing, and we'll see what are the different types of pen testing concepts we have. And I'll go through this OAPS top 10. I'll tell you what is this OAPS top 10. Then you can go with the topic. So in future, if you want to go with the advanced level, so go with the penetration testing. Start means you're done with almost we covered most of the ethical hacking concepts here. So after this, what you want to be in the sense, I suggest go with the SOC. If you're really interested in cybersecurity field, whatever the knowledge you gain is a basic knowledge and intermediate knowledge here. And later you can move on to this SOC or penetration testing field. So I'll give introduction to the penetration testing in these two sessions. Later in future, you can move on to the penetration testing or you can go with the SOC. Okay. So make sure try to complete your tasks. So we left with two more sessions only. So try to go with the task, everyone. All right. So we'll stop it for today here. So thank you for attending the session. Have a great day, guys. See you tomorrow. Yeah, thank you. Team will share that link. Yeah. Is there anyone from Black Box? They'll share the link. Wait for a while.